All right. Okay. So this is the inequalities. The first one is this type. So this is the set of real numbers S. Numbers X between A and B. A and B are excluded. Right? Or may sometimes also use this notation here. So A hole, draw a hole there. Okay. So this is called the open interval. Okay. In contrast, you have X between A and B. But here A and B are included. So the notation is something like this. So you use the square bracket in the graph notations, the square bracket here. So everything's between A and B. And sometimes you write this one also. I use it quite often. Okay, there is a dot here. Solid dot. Here a whole dot. Okay, so this is everything between. This one is called A and B are included. So this closed interval. Okay. And you have also this one. A excluded, but B included. Right, this notation, interval notation is A excluded, B are included. Okay, so here we have A excluded or okay, so this is a hollow dot at A and then solid dot at B. Okay, this is hollow dot. This is solid dot. Okay. Or we can say that this is the open at A, close at B. Okay. And the other hand, you have also X. You close at A and open at B. So you have A, B, and the notations B. This is solid, this is hollow, or this one, notations. Okay. And there is some special interval, inter X bigger than A, for example. Or we write this down as A is excluded, right? But everything to the right of this. Sorry, it should be infinity. This is only notations. So everything's to the right of A. Okay. So you have also A is excluded. Okay. So you notice that the infinity has it's never a bracket or never a solid dot because infinity is not number. So this is a solid dot. And to the left, so it's the same. All right, so negative infinity to A or negative infinity to A. Okay, here you have, sorry, this is not a solid dot. Or okay, so this is the interval notations. Okay, so how to solve inequalities then? All right, so inequalities. Compound inequalities. Doesn't matter. All right. Um, uh, there are some rules that you the first one, you may add same numbers to both sides, to all sides, the same thing, size of inequality. And you can multiply, you may multiply positive numbers to both sides. Um, the third one, if you multiply negative numbers to an inequality, reverses the inequality. Right? Okay, so that's the okay, we solve okay, so what we do here, so you for example, you can let's see what to do. You can add negative 2x on both sides. Okay. Add say negative 2x both sides to get yes negative x, so that's -7. Here you have what we call negative 2x, and you can add also both sides. Right, so you have -5, and you can multiply by 1/2 both sides, so you get okay. So the solution set is is x, set of x, bigger than this one. So this, you can write this down as -5 half to the right. So everything to the right. So interval notations. Okay. And you can also, example 1, example 2, compound inequality. With compound inequalities, something like solve this one. Okay, so let's see. Let's delete the 6 from the middle. So let's say you add. All right, so I just denote by that the operations. So you get x, you add 6, you add 6, sorry, just 10. All right, and then times 1/2. So you get x between 5 and 1. Okay, so here now the solution is x between 1 and 5, or interval notations, this is a 1 is included, 5 is excluded. Okay, so that's the solutions. Or the quadratic now. Let's see. Which one we solve? Okay. Now I would suggest that you solve it as a sign problem. Okay. What is sign problem? Sign problem is this one, or something, or doesn't matter. Okay. So you solve things like the find something positive or find something negative. Okay. So how to solve this one? All right. So here is you subtract 6, right? So you get x squared minus x minus 6. Now this is the sign problem, right? So okay, so what we do is, let's see, this can be factored. Factorization is one of the most important thing in solving inequalities, or maybe equation also. So you can something like this. Okay, so how to solve this one? All right. So we, because there's a sign problem, this is a product. So some product has a, this is positive sign, right? Positive is possible if both are positive. Okay. Or both are negative. Okay, so how you solve this? Okay, with something that we call sign chart. Okay, so for example, x minus 3, change sign at the number 3. To the right is positive, to the left is negative. Okay, what about the chart for x plus 2? This is negative 2. To the right, negative 2, the sign is positive. To the right of negative 2 is, sorry, to the left is negative. Right? So if you multiply those, you get x plus 2, x minus 3. You have to sign something like this. Okay, plus plus become plus, minus minus become minus. Here's minus minus become plus. Okay, so this is the sign chart for this one. X plus 2 times x minus 3, product of two factors. Okay, so what we're looking is the one with a positive sign. So this gives you something bigger to the right of 3 or to the right of negative 2. Okay, so the solution set is to the left was negative 2. It's excluded. Okay, and let's see. Okay, is it clear? Okay. We'll use this a lot. It's a sign chart. Okay, so for example, if you solve um, oh, sorry, not plus. So x minus 4, for example, find something negative. Okay, so just using sign chart, if you proceed like this one, so find the sign chart for every factors. So sign chart for every factors. So it has 4 factors. Dot dot dot. In the end, what you have is something like this, because this is 1, 2, 3, 4. Okay, so how to determine the sign? So just for example, you can plug in 5, for example. You plug in 5 or every numbers to the right of 4. This is positive. Yeah. This is positive. Here's this positive. Here's a, because you a positive and then you square. This is positive also. All positive sizes become positive. Okay. And if you across 4, 4 between 3 and 4, this number is negative, but everything is positive. So they become negative. Across 3. Right? Across 3, what happened to these numbers between 2 and 3? This is negative, negative, positive, positive. Right? And between 1 and 2, between 1 and 2 is negative, negative. This is positive. This is positive. So this is still positive. And here, if you check, this one is negative. Okay, so here the solution set is, let's see, what we're looking is negative. All right, so from to 1, then, oh, between 3 and 4. There you go. Okay, questions? All right, so let's do something. For example, this one. All right, so let's use the sign chart, right? Now, this is the easy thing about sign chart. The nice thing, convenient. You see, let's see. The thing is 0. When the factor numerator factors 0. So that's 1, 2, 3. Sorry, should put the here. 1, 2, 3. And the thing is, the denominator is 0 at 4 and 5. But at 4 and 5, the inequalities is undefined because this would be division by 0. So that's why it's now a hollow there. Okay. Right. Okay, now check the sign chart. The sign chart would be to the right of 5. 5 is uh, the numbers that we position the rightmost of the numbers there. Okay, so everything else here is positive. Across 5, now you see that uh, you have to find the power here. If the power is even or odd, then that's the makes difference. Okay, so across 5, it will change sign. Change sign because this is positive, then become negative. Across 4, it change sign again. Across 3, it changes sign. Changes sign. Across 2. All right, now the factor 2 is the factor from here, which has exponent 2, exponent square, right? If you square, it is positive. So positive doesn't change sign. Okay, so it remains negative. Across 1, because this exponent 1, it changes sign at 1. Once it become plus. Okay, so just there. So the things to remember is this exponent, even exponent. You keep sign. Odd exponent, keep sign. Okay, so that's why the solution is easy. So we're looking for positive or 0. Okay, positive or 0, that should be 1, right? And let's see here, from 3 to 4. 4 cannot be included. Why? Because here and there. Okay, that's the solution set. Questions?
Sorry, sir, I'm still slightly confused on how you determine if it's positive or negative for the sign chart.
So the thing here is that here, the sign for this, okay, that's the reason I changed this is the problem of sign problem, because here, this is sign problem, because you determine positive, negative, okay? All right, if this is one or something not zero, then you still have to simplify that, make it a sign problem. All right, first thing. Now you have to check, basically you indicate all the numbers here, which is the zeros of the factors, all the factors here. For the factor x minus 1, the factor, the zeros is 1, right? For x minus 2, the zeros is 2. The zeros are the numbers which make the factors equal 0. Okay, zeros of a factor. 3 number here is 4 or 5, right? So indicate this number. So basically you plug in numbers. Pick 6, for example. If you plug in 6, this would be positive, 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 positive. Everything's positive, so this gives you positive, right? And of course, you can pick 4.5, for example, here. 4.5, plug in to this numbers here, to the quantity here. 4.5, this make it positive, positive, positive. But this is negative. Sorry, this is positive, but this is one negative. Everything's positive with this one negative that make it negative. All right, across 4. So you pick 3.5. Okay, so basically you can work like that, just picking a number in each. But there is an easy way to think about this determining sign, is by noting that, okay, here's the catch. Think about crossing these numbers. Okay, for example, we start from the left. Okay, so let's indicate this. Okay, crossing this one. Okay, so when you cross 1, your sign will only be determined by x minus 1, by this factor. Okay, everything else, that won't change sign across 1. Right? The only thing that changed sign is because of this factor. Okay, so this is sign across x equals 1, determined only by only. Okay, so then let's depend on the sign for x minus 1. The thing here is that x minus 1 has a different sign to the right or to the left. To the right is positive, to the left is negative. So it will change sign. So if you multiply, yeah. To the rest, okay, because it changed sign, this will change sign. Okay, so if you have a positive here, then because it changed sign, it's become negative. Or if you have negative here, it becomes positive here. Okay. So now what about this one? Okay, so what about across 2? So the sign uh, across x equals 2 is determined only by x minus 2 squared. Okay, but this fact, but because this is squared, it's positive to the right and also positive to the left. So when you multiply everything, the rest of the factors by x minus 2 squared, you multiply by positive to the right, by positive also to the left. Okay, so multiplying by positive number doesn't change the sign. Okay, so here, multiplying by does not change sign. Okay, so which is positive remain positive, negative remains negative. Okay, so you can generalize that further. This power 1, for example here, x minus 1 power 3. Okay, if you have sign is positive, negative, right? So across next line, you change sign because you're multiplying by positive to the right, negative to the left. So the change, the sign will change. Okay? But if you, for example, 6, sign is positive, you will keep the sign. Okay, so using this strategy, let's go back to this one. That's easy now because you indicate these numbers 1, 2, 3, 4, 5. All right, and just check one number, 6, for example, because you plug in 6 or something bigger than 5, any of these factors, then everything is positive. It's positive. Okay, so just proceed based on whether you have to keep the sign or change the sign, right? So you see here that you keep the sign only at across 2 because this has an even factor. Okay, everything else has exponent 1, which indicate you have to change the sign. All right, so across 5, you change the sign from positive to negative. Across 4, you change again the sign. It becomes positive. Across 3, change the signs to negative. Across 2, well, this is the only factor which has even power, so you keep the sign. This is because it's negative, say negative, and then you change the sign again at across 1. All right? So this become easy. Okay, questions?
No, sir, thank you.
All right. Okay, so last thing.
Actually, wait, can you go back to the keep sign rule? I want to take a screenshot.
Which one? Which one?
The one at the bottom.
You mean here? This one,
Yeah,
or
this
all
one?
right.
Hold on. Sorry. Okay, thank you.
All right. Okay, we'll keep coming back to that kind of inequalities anyway, so you'll see later on. Last thing today is about absolute value. Okay, so let x be a real number. So we call the absolute value of x is with the left and right bar. Circling this x. This is defined by, well, if x is non-negative, then keep that one. But if x is negative, you revert the sign by putting a negative. All right. So where does the sign? So to the right of the zero, you keep it. You keep it. To the left, you make it positive by changing the sign. Okay. So properties is that no, just example. For example, 5 is 0, 4 is 4. Absolute value of -3 is 3. Okay, seems that you just forget the sign. Let's put it here. Okay. So some properties here. First thing is that if you take a absolute value of number, then this is 0. Okay, and if and only if x is 0. Okay, and the second is the, let's see, all right. If you add two numbers and then take absolute value, this will be less than each one of the absolute value, sum of absolute value. Okay. This is called what we call the triangle inequality. Why is that the triangle? Triangle is because, well, we'll draw the graph later on. All right. So something looks like this one can be interpreted as the as distance from x to y, or from y to x, because distance doesn't change. Well, does not depend on the whether distance from Jakarta to Bandung or from Bandung to Jakarta, that's the same thing. Okay. All right. So as distance, that's the same thing. Okay. So if you, whoa, sorry, screen sharing. Okay. Right. Okay, here. X, y here. So the distance here, if in these positions, distance is, so if you compute distance, you subtract x from y. So that's mean this one positive. Or if you have this distance, you switch the position. This is y, this x. Then distance is basically right minus left. Sorry, right minus left. Always this order. Okay, so this. Okay, so you can see this one as a distance. And as a distance, you will see that if you have this is x, if you think this is a factor, and the length of this factor is x, this is the length of this is y, and as a factor, this is x plus y, right? And the length of this is bigger than the, sorry, let's see. The length of one side of a triangle is always less than the sum of the other two. Right? So in this case, it's less than the sum of the two other sides. So in a triangle, length of one side less than the sum of length other two. So that's why it's called triangle inequality. Okay. All right. So the thing with this absolute value is that we will have something like this interpretations. You can check if x the ideal value. Sorry. Is this a measurement? This is the ideal. Then the absolute value of the difference is something that we call error. Okay. So when you measure x, say someone cut a cut a paper about 20 centimeter, okay, with a scissor. 20 centimeters, we'll see. What you cut is never exactly 20 centimeters. Okay. So X the measurement, 20 centimeters, and the difference is the error. Okay. Cut 20 centimeters of paper. Okay, so this is the error. And the thing is, something that you want error is, you want error less than 1 centimeter, for example. Okay, so that means x minus 20 is less than 1. So here x cannot be, the least of x is 19. The largest x is 21. Okay, so that's all right. So that's the objective of what we are going to do next week. So describe this in terms of error. So we're back to the what's the problem that I mentioned yesterday about making a spherical water tank of certain volumes, and we try to estimate the error. Okay, questions? Right, I will stop the recording.